Good morning, afternoon, or night, whatever you're watching this. We are in algebra. We're in the third week, and we are doing graphing relationships. Okay, so first thing I need you to do, as with the last couple weeks, make sure you guys pause the video and write all these vocabulary words down. These are all the vocabulary words. It's all about graphing. It's all about coordinate points. It's all about all these things. And if you haven't done graphing in a while, don't worry about it. We're going to go over it. Now, first thing you need to know, right? Let's do this. Relation. We're going to use this word a lot. Relation is just a set of ordering pairs, also known as a coordinate point. That's not the full definition of what a relation is. It's what we're going to be using for like a kind of a shortcut. Another way of saying relation is just a short way of saying like a relationship. And a graph usually is showing the relationship between two variables, usually between an x and a y. Now, why is this important? It's important because uh, the key with graphing relationships is that we graph coordinate points in the hope that we will find a linear relationship or a relationship that is like that forms a perfect line, like a perfect diagonal line, whether it's this one or whether it's this one, but not a vertical one, not up and down. We can't have that. That is not a relation, right? And we're gonna go into why that is. But in general, relation is kind of what we're. If I give you a set of coordinate points, you need to tell me if it's a relationship or not. If there's a relationship there, if it's a function or not. Uh, you need to be able to graph a relation. You need to be able to put them in a table. You'll need to be able to put them in a mapping diagram. Those are all the things that you're expected to do by the end of this week. Okay, cool. Moving on to the next one. Domain. Domain is all possible inputs of a relation. I have here an example, 1, 2, 3, and 4. These are all possible x values or the ordered pairs. Again, if you're having trouble visualizing this, I'm going to put an example down here. But just for now, write them down and it'll make sense in a bit. Range is all possible outputs of a relation, 2, 8, 12, 16, or all possible y values of an ordered pair. Okay. And then we kind of have a little bit of two different lessons mixed in here because again, we don't have a lot of time and I'm kind of just want to give you a breakdown of a bunch of different things. So this other thing, continuous graphs. Graphs that represent real world situations and are drawn without interruption. Graphs made up of connected lines or curves. Examples include modeling time. I'll go into a little bit of what that looks like. But generally speaking, if a graph makes a line, if all the dots are connected, it's called a continuous graph. And we usually use that to model things that happen in real life, things that don't involve interruption, things like time, things like distance, things like there's a bunch of different things that we use continuous graphs to show. But usually it's something happening over time. That's the most common example. A discrete graph, on the other hand, it can be used to show a different kind of relationship. It's used to show kind of like data points, more like statistics. It's more of like an abstract concept, not necessarily a real world tangible thing that you're trying to measure. Discrete graphs are made up of distinct, unconnected points. Examples include a graph comparing test scores in class, right? Notice the word comparison there instead of modeling. Again, I'm throwing a lot of vocabulary at you, but just you know, do your best to just write everything down. And then there's the last one, right? We're going to do this very last. The vertical line test states that a relation is a function if and only if the vertical line does not pass through more than one point in the graph of the relation. Okay, we'll get into that one at the end. But for now, why don't we go into what we're talking about with coordinate points? If you haven't done this in a while, you might recognize this. This is what we call a coordinate plane, or part of one, anyways. Okay, so let's see, where is it? Okay, there it is. Okay, so we have like a graph. We need to put points into place. Usually, what you'll have is something like this. Hopefully, you've seen something like this before, but maybe you don't remember all the rules, but that's okay. What you need to know is what this has to do with the graph, right? Well, the x value, this, are what we call your domains, and that's one of the vocabulary words. Your y value are is the range. And each one of these tells you what number to look for within this graph. So for example, all of your x values are going to be from left to right. And they're these values that are down here. Like they're supposed to be numbers here, right? Right? These are your x values. And usually your x value uh, has some kind of value attached to it, has some kind of label attached to it. A common one, like we were talking about time, maybe your X value here represents ages, right? Like the age of a person, how many years they've been alive, right? And the Y values represent all the numbers going up and down, right? If the X values represent left and right, the Y values represent up and down, right? And the Y values also represent something else too. Um, let's see, what would be a good thing for them to represent? Something like heights. We're going to go over this later. Let's say, and we're going to use this example in the next slide anyways, but I'm just going to show you this right now so you have some idea. Let's say we were trying to measure the heights of all the boys in a classroom, right? They're all the boys in the classroom, or in an elementary school, because we're talking about people that are 1 to 6 years old, right? Because that's the ages down here, and we wanted to know their heights, right? Something like, I don't know, 20, 40. Right? And heights in inches or something, right? I mean, this is just an example, but this is how we would determine it. Like, let's say someone who's 4 years old is, I don't know, 40 inches tall. I actually don't know how tall that is, but I'm assuming that might be a very tall kid. Either way, every single thing, like for example, this will correspond to this. The coordinate point has an x value, right? And a y value. So the coordinate point for this particular dot, the x value always goes first, right? So the x value in this case would be 4, comma, our y value. Our y value in this case is referring to heights, and the child is 40 inches tall, right? So my coordinate point for this particular child would be 4 years old, x value, with a height of 40 inches. And their age and height has been plotted onto this graph. And if we plot the coordinate points for all the other kids, we're going to end up getting a line or something resembling a line. And if there is no repeated x values, right, then that means that there is a linear relationship, right? That means that that it is a relationship that can be easily measured. So let's say every single boy in the world is exactly 20 inches tall when they're 2 years old, and they grow exactly 10 inches every year until they get to, I don't know, 18 or something, whatever, right? Um, then there would be a linear relationship, right? It would be very easy to predict how tall they would be the next year. Now, obviously, we know that in the real world, that's not true. There is no linear relationship to a boy's age and the height of that boy, because everyone grows at different rates, right? And not everyone ends up the same heights. So we know that there isn't a linear relationship, but if we were to graph people's heights, we would be able to visually see that in the graph. And that's what you guys are going to be doing. You guys are going to be determining, is there a linear relationship? Is this a function? Is there a relationship between these two variables? You need to be able to identify them. If I were to just give you a graph, you should be able to identify if there's a relationship. If I were to give you just the coordinate points, right? If I just give you a bunch of these, you should be able to tell me, is this a relationship by just looking at the x values and the y values? You should be able to put them into a mapping diagram and you should be able to tell me what the domain and the range are by just looking at the either data set or the graph. Okay, now let's move on to the actual lesson. How to graph a relation using a chart. Pause the video at this point if you need a break, if you need to just let everything I just said settle in. I don't know how long this video is going to be, but hopefully it's not too long. So just hang in there. All right, problem. For the following relation, comma, the x input is ages of boys and the outputs y is their corresponding heights in inches. Find the domain and the range, then fill out the input table and graph the table. Okay. And they're giving us all the coordinate points because they gather all this data for us, right? So if we look at here, we have a coordinate points. We have 741, 845, 949, 1052, 1053, 1153, and 1259. Again, this is the example from earlier. Let's say I didn't know the results. Let's say I'm a scientist or whatever, and I'm trying to figure out if there's a relationship between a boy's heights and their age, how old they are. And then I took these, let's see, 1, 2, 3, 4, 5, 6, 7. Right? 7. Yeah, 7. I took these 7 boys, I took their ages down, I wrote them down. I took their heights and I wrote them down, and I organized them in terms of a coordinate points. And now I want to see if there's a relationship between these two variables, right? Okay, so now we're going to do this. So step 1, right? If you haven't already, make sure to copy down the problem, the coordinate points. You don't have to write down the interpretation, just listen to it. You can write it down if you want, though. Interpretation. Okay, first we're given a coordinate points already, and we need to graph them. That is the goal. But before we can do that, we need to identify all of our x values, which are all of our domains, and all of our y values, which are our range, and put them in the chart. Okay, step 1, identify domain and range. So we know that all the x values are going to be our domains. So, right, this is my domain, this is my domain, this is my domain. Why? Because remember, in a coordinate plane, a coordinate point is just x and y. And the x always, always, always goes first. And the y comes after, right? Think of like the alphabet. The x comes before the y in the alphabet, right? Well, they're arranged that way for a reason, okay? The x will always go first so we can figure out what our domain is every single time, right? So I'm just gonna real quickly just do this so you know where I'm getting my domains from. My domain, I wrote them down, and I wrote them down like this. I wrote them down in a parentheses. Sometimes you'll see in the textbook this symbol, right, that I have here, instead of the parentheses. I use parentheses because I can't figure out how to do this symbol, right? Right here, this symbol. I can't figure out how to do that in this format. So I just use parentheses, but it's the same thing. It's just a way of organizing your information. Your domain is 7, 8, 9, 10, 10, 11, 12. That's very important. That number doubled, and that's important. All right, we'll keep an eye on that. But for now, we just list them. That is our domains, right? Um, our range is all our y values, right? If you're wondering why I'm using y instead of like r for range or something, it's because I realized I was writing y before I was talking about range, but it's fine because it's the same thing. Excuse me. Let's see. Okay, so now that we have our domain and range written down, we move on to our next step. Step 2, identify what x and y represent. Luckily for us, right, the problem already told us that. The problem says that the following relation, the x input is of ages of the boys. So we know that x represents the boys' ages. We also know that y are the boys' heights, right? Why did I make this an entire step if it's already in the problem? Because what I noticed from last week was that, for better or worse, a lot of you guys weren't reading the problems and you weren't identifying keywords. I'm trying to let you know that it's important for you guys to identify all the keywords. There's a lot of information given in a lot of these problems, but sometimes we skip over it because if we only read a problem once, we're gonna miss information. That's just kind of what happens when we only do things once, right? In math, you kind of have to make sure you figured everything out, right? You got to make sure you read over the problem more than once, right? And you have to make sure you identify all the information that is given, separate it out. And that's what we're doing. That's why step two is a thing here. I'm simply stating X is the ages of the boys and Y is the heights. And that's going to be important when I organize my graph. Okay. Meaning, right? And what does this mean in terms of a single unit, the X and Y, right? What does it mean in terms of this right here? Well, let's take a look at the first coordinate point where it says 7 and 41, right? What does this actually mean? It means that the first boy that we asked, right? It means that the first boy is 7 years old. That's the X value and is 41 inches tall. That is the Y value, right? So with that in mind, right, it gives us a little bit more context, right? Where we're picturing a child and the height of a child, and it's being compared to other people who are older, right? And who are possibly taller. Okay, cool. So now that we know what we're dealing with and we have a more visual example of what's going on, why don't we move on to step three, which is make a chart. Now, if you notice the chart, right, it's just this right here. This is my chart. And I have it pre-made because otherwise it would have made this video much longer if I started making it right now. But pretty much what I did is I just made a T-chart. I know I have a bunch of lines, but I pretty much just made a T-chart. You're going to see me do this a lot, right? The shorter way of doing it is just to do the one I did up there, where I just have an X on one side and the Y on the other side. But for the sake of clarity, I just wrote X values because I want you to know that to the left is all my X values or all my domains, right? This is why I wrote down my domain and range beforehand so that I can just plug them into this chart, right? And if you're thinking that's redundant, you already have the domain and range, why do I need to do a chart? Well, sometimes the problems are going to ask you if you know how to do a chart, and it's a simple matter of filling in the chart. And if you don't know what filling, you don't if you've never seen the chart before, you might not know what to do. It's really simple. It's just your domain and range, right? So if the one of the problems asks you like, hey, fill out this chart, right? And you're like, well, what what do I need to put in the chart? Then you remember, oh, right, in the video it said that if I ever see a chart, it's just my domain and range, and my domain is just the X values, and my range is just the Y values. So I need to put all my X values here and all my Y values here, which is exactly what I did. 7, 8, 9, the double 10, the 11, the 12, and then the corresponding Y values, right? Remember the first boy was 7 years old and had a height of 41 inches. That's why they're across from each other, right? 45, 49, 52, 53, 53, 50, 59. Okay, cool. Um, so what do we do now? Well, now that we've made a chart and we've established what domain and range is, and we know what we're talking about, we're going to just plot the points onto a coordinate graph. Now, we know that these are coordinate points. So we know that when we're drawing the coordinate plane, when we're going to do an X and Y, we know that the boys are my X value, and we know that domain is to the left and to the right. So it's the bottom line here. So I graphed them from 2 to 12 because that's you know, as far as we need to. And as far as the height goes, height is the Y value, and we're going to go up, which is why I have 10, 20, 30, 40, 50, 60 to make sure I capture all of them. Okay, 7 and 41. We're going to go all the way to 7. 7 is right here. Right? And then 41 is, there's 40. There's no 41, but I know that it's right above, right? It's right there. So I'm going to do my best to kind of just, there. I graphed it. That's the first point. It's done. Now, do you have to draw the lines there? No, right? You don't have to draw the lines. I drew the lines so you guys can see why I'm putting that point there, and I'm going to draw the lines for the rest of them. But then I'm going to erase it because, you don't need to draw lines. You just need to draw the point on there. Do your best to estimate sometimes because a lot of the times the actual numbers are not going to be on there. It's going to be little ranges like we see here. Okay, the next one, 8 and 45. So we have 8 here, right? And 45 is somewhere in between. Let's go up here, right? Right, 1 and 8 and 45 is roughly around there. Cool, we have 9 and 49, so 9 and 49. It's a little bit below, but right above it. Okay, the next one is 10 and 52. 10 and 52. Then we have 10 and 53. Okay, 10 and 53 is right on top. And notice this situation is important, right? Okay, and then there's 11 and 53. Okay, 11 and 53. Right. So that should have just been the same line continued. Sorry, like that. Okay. Uh, then it's 12 and 59. So 12 and 59. Okay. So what is going on here? Well, remember how I asked, is this a relationship? Is there a relationship between boys' heights and their ages? Well, kind of. Do you see what I did there? I tried to connect them. There is no linear relationship, as in it doesn't make a straight line because of where the circle is. If you notice, there's two dots, right? A linear relationship would imply that we can predict exactly how tall each boy would be if we know their age. But since there isn't a linear relationship, because we see it's not a function, you see, we can't accurately predict it because what's going on here is there are two boys that are both 10 years old, and one of the boys is 52 inches tall and the other boy is 53 inches tall. So as you can see, there is no linear relationship. But is there a relationship like at all? Well, yes. It's more of a statistical relationship, which is a class that I also teach, but we're not going to get into that here. For the sake of here, no, this is not a relation. There is no relationship in here, even though there kind of is, because as we noticed, right, in this particular data set, even though in general, as the boys got older, they got taller, right? But that's just these set of boys. I mean, that's not true for everyone. Some people stop growing at a really young age, and some people keep growing until the end, right? And the situations where you see a little circle, right, where there's multiple X's, we can't have that. If we have multiple X's, there is not a direct relationship. And there's not a direct relationship, then that is something that we need to know too. Okay. Okay, cool, cool, cool. All right. So moving on to mapping diagrams, right? Because that's what we just did was learning how to graph a coordinate set, right? And that's cool. But what if I didn't allow you to graph it? What if I didn't give you any graphing paper and I just said, hey, here is a data set, here are your domains, here are your range. Tell me if this is a relationship, right? And then you have to determine, is this a relationship without graphing? Is there a way to do that? Yes, you can do a mapping diagram or you can do a t-chart. I mean, you could easily have done this right here in the x value. You're going to see that as the exact same thing. However, mapping diagrams are a visual example. Some people need a visual example, right? When graphing is unavailable, you can do something like this and it's really quick and easy, right? You just list all the domains, like for example here, all the domains are my ages and all my ranges are my heights. I just listed them kind of vertically here and I just started connecting the dots one on one, right? So in this case, right, is there an anomaly? Well, yeah, kind of. Right here. So when we have this situation, remember, in order for it to be considered a a function, we are not allowed to have the same x value, right, twice, right? For we're not allowed to have the same x value twice. And the thing is, for this one, if we look at the list, there is two tens in the x values, right? And we can't have that. A quick look at if that 10 has two lines protruding from it, right? Then that's just something that we can't have. So this is right. It's not a function. It's not a relation, right? It's it's not whatever you're. It's not a linear relationship, right? So a question could be, well, okay, so the x is repeated, all right, but what about this situation here, right here? Y is equal to 53. What about this? Okay, so x's are not allowed to repeat. Why is the y allowed to repeat? Well, that's a good question. Let's look back at this graph here, right? What is the big difference between uh, the 10 and the 53? Well, the big difference is what they represent. Remember the meaning part right here? The meaning says the first boy is 7 years old and is 41 inches tall, right? What this is saying is that so far the only time that this pattern breaks is in the 10, because there's two boys that are 10 years old and they're not the exact same height. If this is a linear relationship, they should be the exact same height. But if we also look at 53, right, inches tall, right, we also have a 10-year-old that's 53 inches tall, and we have an 11-year-old, which are 53 inches tall. You are allowed to have multiple uh, Ys, right? Because what happens is this is happening as opposed to this. We're not allowed to have vertical lines. We are allowed to have a horizontal line, because really what's going on there is that doesn't have a slope, right? And the vertical line, even its slope is undefined, as in we can't calculate the slope. And I'll go into a little bit more about what that means later, but just know that for now, the shortcut, right, is you're just gonna have to remember this rule. I mean, x's cannot repeat, but y's are allowed to repeat. And a little bit something of why that is, another explanation for why that might be is this next part. We're going to get into a vertical line test, okay? And for the vertical line test, you might be wondering what that is. Well, in our definitions, you should have in your notes right now, vertical line test states that a relation is a function if and only if a vertical line does not pass through more than one point on the graph of the relation. And everything I just read out the definition, and you should already have that written down, because if you wrote it down from the vocabulary. So I hope you didn't try to frantically write down what I said, right? Because you should already have it written down. And if you don't, then you got to return to the first part. Okay, so the vertical line test, what is it? Well, if you're ever unsure as to whether or not a graph is a function, right? A linear function, if anything, you can always apply what's called the vertical line test. And this would be like if I didn't give you any coordinate points, right? Like at all. Like let's say I just gave you uh, a completed graph and just ask you, is this a function or not? You should be able to look at it and be like, yes, this is a function, or no, it is not a function, because it either passes or fails the vertical line test. Now, what does that mean? Well, if you look at this example right here, right, we have a line. We have a diagonal line that starts from here and then kind of goes on here. And it looks like it's going on forever. And what's going on here is that every single x value, right, only has one x value. That's all it has, right? Because what could happen, right? And you might be wondering, like, okay, well, there's that rule again. There's that rule that says that x's cannot repeat, but y's can, right? So what does that actually look like in terms of the vertical line test? Well, the vertical line test, let's see, let's give these numbers. 1, 2, 3, 4, 5, 6. The x's don't repeat. This x is a 1, this x is a 2, this x is a 3, this x is a 4. I don't have two dots on the same x value. I also don't have two dots on the same y value, right? But know that that's not necessarily a deal breaker, right? If I have something like this, that may not be necessarily a linear relationship, but there's definitely a relationship going on because it passes the vertical line test. So what is the vertical line test? It just means that uh, if I was to put a vertical line, right, through every single x point or x value, would the dot, would there only be one dot on that line, right? And again, what that means is what I did here, right? I drew a line and I went all the way through, and there's only one dot on that line. What about this vertical line? Well, there's only one dot on that line. What about this one? There's only one dot. What about this one and this one and this one? There's only one dot per line, right? Even if I were to look at this example up here, there's a vertical line here, there's a vertical line here, there's a vertical line here, here, and here. The vertical lines only touch one dots, right? What about this horizontal line right here? It's just straight across. Well, let's check if it passes the vertical line test. Vertical line, vertical line, vertical line, vertical line, vertical line. Did any does any of those vertical lines that I just drew have more than one dot on it? No, it has one dot each. Cool, it passes the vertical line test. All three of those are examples of functions, right? Of relationships. All right. What about the other sides? What about the ones that don't pass? Well, let's take a look. In this case, I have a situation like this. Right? Okay, so what's the difference between this one and the other one? The difference is, if you notice the second vertical line, how many dots does this have here? There is 3 X's for this one line, and we can't have that. On top of that, there's another violation up here. There's 2 X's and only one line there. So it is not considered uh, a function. It's not considered a relation, whatever you want to call it, right? Okay, so what about an entire vertical line, right? We've established that a horizontal line does pass the vertical line test. Does the horizontal line pass the vertical line test? Only if there's only one dot on it. If there's multiple dots like this, if all the dots in the graph are in one vertical line, then that definitely does not pass. That would not pass. And again, this has to do more with the slope because the slope of this vertical line is what we call undefined. That means that we can't actually calculate the slope of a vertical line, but the slope of a horizontal line equals 0. And why am I bringing up something that wasn't on the vocabulary, slope and this undefined? We're not going to talk about it much this week, but we are going to talk about it in week 4 and week 5. So I'm just introducing it right now. Keep it in mind. Next week, we're going to use it a lot. So yeah, be ready for that. Okay, cool. Last thing, totally not important. Just kidding, it is. Discrete versus continuous graph. What is that? What is that? Okay. Remember how I said in the beginning you have vocabulary words that have to do with this? Let's just take a look at this. Continuous graph is a graph that is connected and uninterrupted, right? Usually what that means is we model it in time. It can be linear. It also doesn't have to be necessarily, as long as all the dots are related. The dot before it, right, helps to determine the possibly determine the dot after it. They're all connected in some way. So in this case, for example, distance travel, let's say you're driving a car, right, and you're going 40 miles per hour or whatever, um, or 40 miles every 5 minutes, right, which is very slow in comparison. But let's say every actually that's very fast. Actually, I'm thinking about it in the reverse. Yeah, let's say you had a super fast car and you can travel 40 miles in 5 minutes, right? If you maintain that speed, would we be able to graph your speed and your distance traveled? Yes, because it becomes a pattern at this point. Yeah, I know those aren't straight lines, but you get the point. Time in minutes, right? As time progresses, distance traveled progresses at the same rates. That is a continual graph. It is uninterrupted. All the dots are connected, right? Okay, what about a discrete graph? Well, a discrete graph isn't very well applicable in the real. I mean, I guess it is, but only in certain situations. Discrete graph is more like describing something. It kind of lets you know something, but the point is they're not connected. The dots are in the graph are not connected at all. For example, points on a test and number of problems correct. If you get 2 problems correct, you get 20 points, right? Okay, cool. If you get 4 problems correct, you get 40 points. Cool. 6 problems correct, you get 60 points, right? But one does not necessarily depend on the other, right? Because if you're a student and you're taking this test, you can only have one of those dots as your score, right? Because if you take the test and you end up getting an 80, right, that means that you got 8 problems correct on the test. But you can't get 8 problems on the test correct and also get 6 problems on a test correct. That just doesn't make sense. You can have one of those dots, right? Or none of those dots, but they're not related in any way, right? So that's the difference between a discrete graph and a continuous graph. Um, we're not going to talk too much about it. I had to go over it a little bit. I'll try to pick out some problems where you're identifying these things and whether or not uh, whether or not it'll help. But for the most part, that's it. Um, and hopefully, you know how to graph now. And if you don't, make sure to email me or send me a private message saying that you want to Zoom. Just a side note, guys, I'm doing my best to respond to you guys during the weekend, but just know I do have a lot of things to do on the weekend as well, like everyone. And if I don't immediately respond to you, it's not because I'm ignoring you. It's just that I I don't always have the time. I'm not always checking, right? So the best times to get in contact with me is throughout the week, right? If you ask me questions throughout the week, Monday to Thursday, you'll definitely get it answered soonish, sometimes right away. If you try to ask me questions in the weekend, like Saturday at 3 in the morning, um, I probably won't see it until the next day, right? And it's one of those things that I know it's hard, but if you guys uh if you guys have the time to work on this stuff throughout the week, you really should. Even if it's just looking through all the problems and then seeing which ones you can. If there's a problem that you're like don't understand right away by just looking at it, it's a good idea to note that problem and then send me a message like, "Hey, can you give me an example on this problem?" But send it throughout the week so that I'm more likely to get back to you right away. And then that way, when you do look at it on like Saturday, you have an example already ready to go. Does that make sense? Well, hopefully it does. Anyways, good luck and thank you guys.